Hi students, welcome to today's class. Today we are discussing about the first topic is internal memory in 8051. So there are three internal memory are located in 8051. That first one is special function register. So this is a register present in the processor. These registers are used to program and control various on-chip hardware peripherals and features of 8051. Okay, so this is a special first function register is nothing but it's a register inside the processor and it's used to for program and some hardware peripheral and features of 8051 hardware on chip hardware programs and the programs inside 8051. So this is called special function register. The second register is internal RAM. So we know that internal RAM is used to store the data and also internal RAM of size 128 byte. Okay. So RAM inside the system chip but it is outside the processor. RAM also inside the system chip, that is in 8051 the RAM is included in the system chip but it is outside the processor. Likewise internal ROM also inside the chip but it's outside the processor. Okay. So in RAM it is used to store temporary data provided by the programmer. So it is called data memory. Okay, the data are saved in temporarily in RAM. RAM of size 128 byte. Now we have internal ROM. It's of size 4 kilobyte. Here it is inside the system chip but outside the processor. Okay, so it contains program for set permanently by the programmer. So this is permanent program code. Then the RAM is temporary data memory. Okay, so it is called program memory. Okay, so these are the three memory types of 8051. Okay, now we can discuss each in detail. Okay, so first we want to discuss the internal RAM organization of 8051. Okay, we know that internal RAM is of 128 byte. Okay, so this 128 byte can be divided into three categories. The first one is register bank, the other one is bit addressable area, and the third section is general purpose area. So the 128 byte of internal RAM is divided as first register bank section, a bit addressable area, then general purpose area or scratch pad area. Okay, so in these internal RAM contain bit addressable and byte addressable. Okay, what is bit addressable and byte addressable? We can select bit by bit. Okay, this is 128 byte of RAM. So this is register bank. So we have already studied in PSW how we are selecting a register bank. So in PSW, that is flag register, we have the third and fourth pin for selecting register bank 0 and register bank 1. So register bank has each bank is 1 byte of size. Okay, sorry, each bank is 8 byte of size. Okay, so when we are considering the register bank 0, it can be elaborated as like this, that is R0. Register bank 0 is 8 byte and it is of R0, R1, R2, R3, R4, R5, R6 and R7. This is register bank 0. Similarly, the same will be repeated in register bank 1, 2 and 3. Okay, so this R0 is of 8 bit, R1 is of 8 bit, R2 is of 8 bit. So this R0 to R7, these all are registers which will be used in our 8051. So these registers are of 8 bit size. So the register bank is, so this R0 is 8 bit, R1 is 8 bit. So in total, we have a register bank of 8 byte size. Okay, and register bank 1 also has 8 byte size. So among 128 byte, 38 byte size is taken by register banks. Okay, and then the remaining, okay, 32, that is, this is of 8 byte, 8 byte, 8 byte, 8 byte. So 8 into 4 is 32. 32 bits are taken for register bank. Then 20 to 2F, this is the size of bit addressable area. Almost 16 bytes are used for bit addressable area. Remaining 80 bytes are used for general purpose area or scratch pad area. In total, we have 128 bytes. Okay. Then this register bank is 8 byte and addresses start from 00 to 07, that is 00, 01, 02, 03, 04, 05, 06, 07. Okay, this is bank 0. Then next bank 1, we have the address 07. After 07 we have 08. Then 08, 09, instead of 010 it is hexadecimal, so we have 0A. Instead of 11 we have 0B, and instead of 15 we have 0E. Okay, 0F. Okay, so this is the second register. Then the third register have address from 10 to 17, that is 10, 11, 12, 13, 14 to 17. Then we have 18 to 1F. This is all the address of register bank. Then the bit addressable area address starts to, after 1F we have, after 1 we have 2, after F we have 0. So we have 20 to 2F, 20 to 2F. Okay, that can be right here, that is byte addressable. This is bit addressable because we can select R0, R1 bit by bit, and also it's byte addressable. We can take R0 at a time. So it is bit addressable and byte addressable. Register bank. In this is bit addressable area of RAM is, this is byte addressable, that is 20 to 20F. So we have 20, 21, 22, 23, etc. 29, then 2010. Instead of 2010 we are at 2A, that is 29, 2A, 2B, 2C, 2D, 2E and 2AF. So in total it has 16 bytes. So this 20 byte is elaborated here. 20 byte can be written as 0001, 02, 03, 04, 05, 06 and 07. Then next is after 07 we have 08, 09, 0A, 0B, 0C, 0D, 0E, 0F. After this is we have, instead of 0 we have 1, and F instead we have 0. Then 10, 11, 12, etc. 17. Then we have 18, 19, etc. 1F. Then next we have 20, etc. This way we are writing the address. So this is the bit addressable area of RAM. This is the byte addressable area of this section. Okay, so we have 00 to 7F, that is 16 byte. Remaining, that is the address that after 2F we have 30. Remaining this address up to 7F we have general purpose register or general purpose area or scratch pad area, which has 80 bytes. So this is the internal RAM architecture or RAM of 8051 microcontroller. So this is very important. Okay, so we can study in detail. Okay, in each, okay, each register banks. Okay, then 8051 has 128 byte RAM. It accesses to RAM address register, and it is addressed using 8 bits, and it has 8051 contains 128 bytes of internal data memory. It is organized to 3 distinct area: register bank area, bit addressable area, general purpose area. Register bank area has an address from, this address also very important, that is 00H. Since it is hexadecimal we are writing H. 00 to 1F. Then bit addressable area we have 20 to 2F, and general purpose area we have 30 to 7F. Okay, then we can study. Okay, first one is register bank area. We know that the register bank area we have register bank 0, bank 1, bank 2, bank 3. We have 4 register bank area. So each have 8 byte. So we have in total 32 byte. Okay, which are divided into 4 separate banks. Each register bank had 8 register of 1 byte each. Okay, that is R0 to R7. So we have already looked at each has register with R0 to R7. Okay, 1 byte register. Out of these 4 banks, only 1 bank may be selected to achieve at a time of operation. So among these 4 banks, we are selecting any one of the bank. If bank 0 is filled, we are using bank 1. Then we are using bank 2. Okay, likewise. This reduces the addressing time and generates faster response. Initially, after system reset, bank 0 is selected as default. Okay, so we have already said that in default, we are selecting bank 0. Okay. Register bank is selected depending upon the 2 bank select bits in the PSW register. The PSW register we have the 3rd and 4th bit is used for RS0 and RS1. This is for bank select. If it is 00 we are selecting bank 0. If it is 01 we are selecting bank 1. If it is 10 we are selecting bank 2. If it 11 we are selecting bank 3. Okay, so this is the case of register bank area. The second one is bit addressable area. So bit addressable area, we know that it has 16 bytes of bit addressable area. It is both bit addressable and byte addressable. Okay. So here in total it has 128 bits, that is 16 byte into 8, we have 128 bits. So total the bit addressable area, the total value is 128 bits. Okay. Then next, each bit can be accessed modified by suitable instruction. Okay. Then it store bit variables for application program. The bit address from 00 to 7F, it is the address of bit addressable area. Then we have, for example, bit address 4E refers bit 6 of the byte address 29. Okay, now we can indicate the value 4E in this bit addressable area. This is 4E. Okay. So this is 4E. This 4E as, okay, this 4E as, okay, this is 4E. This has a byte, okay, bit address of 06 and it has a byte address of 29. Bit address of 06 and okay, byte address of 29. Okay, that is written in here. Bit address of 6 and byte address of 29. Okay, then next one is last section is general purpose or scratch pad area. So the remaining 80 bytes of RAM are available for general purpose. They do not have any special purpose or feature. It is byte addressable only. It is not bit addressable. It is byte addressable only. So that's all about internal RAM. Then we can look about internal ROM organization. We know that 8051 has a 4 kilobyte of internal ROM with the address from 000H to 0FFFH. Okay, it is programmed by manufacturer when the chip is built. Okay, it is programmed by the manufacturer at the time of building of the chip. Okay, at the fabrication of the chip. This part cannot be erased or altered after fabrication. Okay, this is used, this is non-volatile, used to store final version of the program. So this is the permanent memory. So we are used to store program here, final version of the program. Okay, it is accessed using program address register. Okay, so that's about ROM. So these are the internal memory of 8051. Then we can discuss about the stack of 8051 too. So the stack, we have already uh, uh, mentioned about stack. Okay, stack is nothing but it's a memory location in RAM. It refers to an area in RAM that is used to store and retrieve information quickly. So in order to store temporarily and to retrieve the information quickly, we are using stack. This information should be data or address. So inside the stack, we can store data and address too. Stack is a set of memory locations operating in last in first out manner. So this is the form of stack. So this is last in first out. So in the stack we are adding some informations or data or address, and we are taking from information too. So when we are adding and taking, it is taken that okay, the last, it is processed in a manner that the last in first out manner. So the last data can be taken first, that is stack. Okay, so this is the top of the stack. So this is the bottom, and this will be the first data. This will be second, third, etc. This will be last. So when we want to take any data or address from stack, we are taking the last one which is stored to the stack. Okay, so deleting an element. So we are taking out an element from the stack. It is called pop. Okay, we are taking out an element or data from the stack or deleting a data from the stack. It is called pop. And when we are this pop is used in the programming. When we are adding some element or adding some data or address to the stack, then we are using the instruction push. So pop is used to taking or deleting some data, and push is used to adding or any data or element. So this is the case. When we push means adding some data. So I add one data, then I add second data. The second data will place over first data. Then we add the third data. So this is called pushing. So we are adding data means push data. Then we are taken out data that is called pop. Okay, so if you are taking the 3, the last is 3 value, then we are taking 3 first, so it is pop. So taking out, it is called a pop. It is used to store return address during ISR and also used by the programmer to store data during programs. Okay, so what is ISR? That is interrupt service routing. So if an interrupt is came during a main program, this is used to store return address of the ISR. So interrupt service routing. The return address of interrupt service routing is stored in this stack. Okay, that is temporary storage. We can quickly take that data and address also. So it's, and also the programmer is used to store data during the programming section. So it is called temporary storage. The register uses to access the stack is called a stack pointer or stack register. So stack register is nothing but the register is used to access the stack is called a stack register or stack pointer. The stack pointer SP register hold an internal RAM address that is called top of the stack. Okay. Okay, then stack pointer use or stack register uses the address at the top of the stack because we are taking data from the top. Okay, the stack pointer register is 8-bit wide. The register is SP register is 8-bit. Then stack can only be present in the internal RAM. Okay, now after reset, the SP register get the value 07H. Okay, so at the reset time, SP, that is the lower part of stack, take the value 07X. Okay, 07. Then if we very first data, it will be stored in location 08. If the first data is came, okay, if the first data is came, if we are pushing the first data, it will be stored in 08 address. If the second data came, it will stored in 09 address. Okay, so likewise it is increasing, while that is the increasing the address while storing data using push and call instruction, and decrement the address after the data is restored during pop and returns instruction. When we are popping or returning instruction from the stack, the address will be decremented. If we are push or call instruction to the stack, then the address will be incremented. Okay, this is the case of stack in 8051. Okay, so that's all about today's class. Thank you.